Good afternoon and welcome to EGU22, the annual meeting of the European Geosciences Union. As many of you already know, this is the Union's first hybrid General Assembly, where we are bringing back our on-site experience with those joining us here in person, while at the same time introducing new concepts from the last couple of years to include our virtual attendees as much as possible. This year, we've had more than 12,000 abstracts submitted to EGU's meeting. And during today's press conference, we'd like to highlight some of the most unique studies, which, as you'll soon see, have impacts on local communities, industries, ecosystems, and the global environment. I'm Gillian D'Souza, EGU's Media and Communications Officer, and I'll be hosting this week's press conferences. So each press conference will have time for speakers to make their presentations, followed by a question and answer period at the end. For those of you joining us virtually, I ask that you mute your mics throughout the briefing until I call upon you to speak. If for some reason you experience technical difficulties, you can try to rejoin the session or look for more information on the press conferences section of the media.egu.eu page. Last couple of things to note. Please save all of your questions for after the speakers have done presenting. During the Q&A period, we will take questions from journalists in the room and online. If you're in the room, please raise your hand so that we can pass a microphone over to you. And if you're joining us virtually, you can use the hand raising function on the Zoom platform so we can come to you for your question. And if you prefer to type your question instead, that's fine too. Feel free to do so in the chat. All right, so now I'm going to go ahead and introduce our panelists to make for faster transitions between them. Today's press conference is titled Junocam and Citizen Science, NASA's Mission to Jupiter. Our participants today are Scott Bolton, Juno Principal Investigator, Southwest Research Institute, San Antonio. He will be joined by Stephen Levin from the Juno Project Scientist, Jet Propulsion Laboratory, and Gerald Eichstädt, Independent Scholar and Citizen Scientist from Stuttgart, Germany. We are now ready to begin our press briefing. So over to you, Scott.
Thanks very much. So welcome, everybody. I'm excited to talk about Juno with you. Today, we're going to go over some new results a little bit, but what the focus of today's briefing is really about two programs that we want to share with you. One is an educational program, and the other is really outreach and how we take our camera, take the images, put it on a website, and citizen scientists and artists and lay people all over the world process our images, and we want to show that story and hopefully inspire you to give it a try. So let me just start off by showing you what you see on the screen there. The title is just a picture of Juno. Just to give you a background, Juno is in orbit around Jupiter. It arrived there in 2016. It's solar powered, so you can see three pretty large solar arrays. It's a very large telescope, or a very large spacecraft because of the solar power. Those solar arrays are about 8.5 meters long each, and it goes through space orbiting Jupiter, cartwheeling, spinning, and the science instruments are positioned, most of them, so that they look out between the solar arrays. And so they each get a share of looking at Jupiter. You see Jupiter behind you, and that's a very familiar picture of Jupiter. It's the kind that we see from the ground. And you can see the great red spot and the classic zones and belts, the stripes of Jupiter going across the middle of it. Now, because Juno's in polar orbit, we actually see a little bit of a different view. Let me see if this slide thing works. Is this? I'm trying all of them. Something changed. There. Did I do that or did you? Okay, so here you see on the right-hand side, a large picture of Jupiter. It looks very different than what we normally see. from the Earth, and that's because Juno is orbiting over the poles, and so it gets a different perspective than we've ever seen before. So here, non-intuitive, without any intuition, you're seeing actually the great red spot looking like it's at the top of the picture, and that's because you're looking a little bit toward the poles, and you see that the zones of belts start to go away, and they're replaced by these big vortex storms, vortices that are going around, and this bluish hue. Just in the middle, you see the spacecraft, sort of the way it spins about 2 RPM as it goes around. It takes about, we're moving really fast, so we go from pole to pole in about 2 hours, and then we spend the next few weeks. The orbits are typically 40 days, 45 days, but in the beginning there were 53, but we spend most of the time away from Jupiter, away from the radiation belts, and then we do a dive bomber type technique. For 2 hours, we get really close to Jupiter, make the main measurements, and then get away as fast as we can. And on the left, you see a close-up of the great red spot. And one of the speakers that we're going to have today actually made that image, and you'll see even not only how he made it a little bit, but a film that we made with it. So today we're going to have a couple of speakers. One is going to do the educational program, and what we're going to describe as a program called Garrett, and it uses an antenna that was being used to downlink data from spacecraft, and here you see a picture of it, and it's now dedicated to a student program where students all around the world, and we want to encourage people in Europe now to join that. High schools, middle schools, get online, they can actually control this telescope, and the kids learn how to do science firsthand. So it's a very exciting program, and Steve Levin will speak next. He's the project scientist of Juno, and he's also the lead scientist for Garrett. And then after him, Gerald will actually speak about citizen science and how he got involved with Juno and went on the website and makes these incredible images, and how he does science with them. He's actually, a citizen scientist, but he's publishing. He gets on publications with us, and he's presenting stuff at this conference that's scientific. So he's basically joined our team, and you all can too. So without that, any further ado, I'll turn this over. I just want to mention one last thing is, many of you may know of Vangelis. He does great music that has really helped us understand the universe and appreciate the beauty and the mysteries of the physics of nature. And he passed away last week, and we've had a long-standing collaboration with him that started way before us. He actually, the music that he did was part of Cosmos from Carl Sagan. He's done some things with me for Mars missions, for lots of different space things. I've been friendly with him for about 25, 30 years. He did some things we did with Rosetta, the space station, and he does a lot with Juno. So we want to kind of honor him. These images, you can see some of his office. He has pictures of Saturn. He's wearing a Juno shirt there. He was definitely a space geek and a great composer. And we're sorry that he passed, and we'll miss him. But we have a special video at the end where Gerald, as a citizen scientist, collaborated with Vangelis and produced a video of flying around the great red spot of Jupiter, and put to music from Vangelis's latest album. So we'll share that with you, and just as in his honor. Okay, so now it's up to Steve Levin. You can control that.
Okay, so I'm going to tell you about Garrett. Let's see if I can there we go. So Garrett stands for Goldstone Apple Valley Radio Telescope Project. And what it is a collaboration, partnership between NASA, JPL, and the Lewis Center for Educational Research in Apple Valley. And our basic idea behind it is we want both the science and the education to be real. So we have students, and now we're adding citizen scientists as well, adults, but primarily still mostly students right now, remotely operate a 34-meter radio telescope. So as Scott said, one of the large radio telescopes that NASA uses to communicate with spacecraft, we can do radio astronomy with it. And the students do real science with it. They do science, they collect data that's going to be used. And we also have the ground rule in our project that they get real education out of it. The teachers and the people at the Lewis Center, who are the educators involved on our end, have to agree that what the students are getting out of it is educational as well. So you can imagine we're trying to inspire people to do some of the great things like what Gerald has done and what the scientists on our team have done. So they're contributing to the body of scientific knowledge. We're helping them learn to think like scientists. And we have 4 basic science campaigns that the students and citizen scientists work on, one of which is Jupiter. And of course, we have a tight collaboration between the people working on Jupiter for Gabriel and the Juno science team. So our students contribute to Juno Science. There's some examples up there of papers published, including our most recent one, which is led by Clara is now a freshman in college, but she started working on this when she was about 17, I think, as a high school student, and actually led our most recent paper on variability of synchrotron radiation from Jupiter in collaboration with people on the Juno Science team. And it's a result that's actually of interest to us and helps enhance the value of the data we collect from Juno. We work with the teachers on science lessons. We help train the teachers to use the radio telescope. We sometimes meet them in the classroom or join them over Zoom. Students have come to Juno events. We had students at the launch. There's a picture there of the then administrator of NASA, Charles Bolton, talking to a bunch of Gabriel students at the Juno launch. And they've come to JPL for when Juno arrived at Jupiter and so forth. I think I'm going to leave it there and pass this along to Gerald, and then you guys can ask me questions about that if needed.
So hi everyone, my name is Gerald Eichstädt. I joined the Juno Mission in 2013, just a few weeks before Earth flyby. Initially, just a few computer-generated test images have been available for testing and developing appropriate image processing software. This already looked non-trivial, and for me at least, hence interesting. Then 2 weeks later, after the actual Earth flyby, Junocam sent back first real images of Earth. They turned out to be even more interesting than the synthetic test cases. At that time, I knew that it will be worth and necessary to implement specific Junocam image processing software. I anticipated that it would take almost all those 3 years until Jupiter approached in 2016 to design and implement camera calibration software and eventually the actual image processing software. I used that time and I did the job. With the first real Jupiter images taken by Junocam and downlinked onto Earth via the DSN, Deep Space Network, it became immediately clear that Jupiter isn't like Earth. It's significantly flattened due to its fast rotation, and cloud top structures are paler than usual satellite images on Earth's surface. So I adjusted my software to fit better to Jupiter's requirements, and I'm still learning. The first slide shows a sequence of 7 Junocam images, all of which have been taken during the outbound branch of Juno's 37th Jupiter flyby, also called Perijove 37. Those images have been taken within a time span of about 1 hour. They are intended to reveal Jupiter's southern dynamics, and I'll show you later that this attempt is indeed successful. The next slide shows a raw Junocam image. This is where the Junocam image processing begins. The Junocam CCD chip returns grayscale images. Color filters fixed on the CCD chip turn the camera into a color camera. 4 filter stripes on the CCD return a blue, a green, a red, and a near-infrared stripe for each take of the camera. The image shows such a take. It is actually using the 3 filters required to compose a color image. Composing a color image requires a geometrical alignment of 3 color components and some intensity adjustments. Think of a typical processed Junocam image being a mosaic with its pieces taken by a camera on a fast-moving and spinning spacecraft. All the pieces have to be distorted and aligned in order to return a consistently stitched entity. The image shown on this new slide is approximately in natural colors, almost like a human would see Jupiter through a telescope from Earth. The colors look pale. In order to bring out subtle detail, the image can be enhanced in various ways. The next slide shows an example of such an enhancement. The focus on this specific enhancement is on small-scale detail. The center of the image shows an anticyclonic storm in the southern hemisphere. In contrast to Earth, in Jupiter, anticyclonic storms occur rather frequently. I've processed all 7 images shown before in the same way. Within the covered time span of about 1 hour, clouds move by a perceptible distance. By composing the processed image sequence into an animation, this cloud motion can be visualized. And this slide shows such an animation. Since we have the distance to the storm, the timing of the images, and sufficiently distinct cloud features, it should be possible, at least in principle, to estimate wind velocities on the basis of such image sequences. I haven't done so yet for this specific storm, but we should expect wind velocities on the order of 50 meters per second, maybe up to about 100 meters per second. My message here is that anyone with an internet connection and the interest can access the raw image files and perform a scientifically valuable analysis of the data. I don't say that's simple, but you can do that with some, with some work. During Juno's first orbit around Jupiter, back in 2016, the spacecraft sent us a pair of images of the South Polar region. It showed the southern circumpolar cyclones for the first time to us human beings. Moreover, we have been able to visualize the rotation of those storms. And this slide displays this blink between the 2 images of this pair. We were able to confirm this discovery during almost all of Juno's perijove passes thus far. Maybe I should add that this image pair was originally taken just for engineering purposes, so nobody did expect that we would actually see new science in this first perijove pass. This slide is about ongoing and future investigations. Note the subtle and fuzzy diagonal and more or less parallel features in these images. I hope it's yeah, okay. Do you see those Haze structures? Yeah, you have to. We are rather sure that we see high altitude Haze structures here. We are working on a better understanding of these observations. In the image shown on the next slide, our focus of interest is on the very distinct cloud structure. The same cloud structure was imaged several times from very different angles within only a few minutes. Therefore, we expect displacements between images to be interpreted mostly as parallaxes of the 3-dimensional cloud tops. We think that we can go a step further and retrieve relative cloud heights in a quantitative way on the basis of this and of similar image sequences. I'll demonstrate the plausibility of this assumption in this slide. It shows a blink between two images taken with less than 4 minutes from very different angles. Even shadows cast by some of the cloud towers can be seen more or less distinctly depending on the angle we are looking at the cloud tops. I hope I can point to that. If you look, okay, if it would, yeah, blink, you might be able to see that there's a shadow along those cloud towers, and with some luck, yeah, you might be able to distinguish the moving shadow, but we analyze those images deeper and we'll squeeze that out. Okay, so now in the next slide, you see a cylindrical maps with a great red spot. The underlying images were taken during Juno's Perijove 12 flyby. I have used this map as one basis to derive a flyover movie. And it was really a big pleasure and honor to collaborate with Vangelis during this project, who very sadly passed away last week, like we heard before. In memory of him, I conclude my part of the presentation with this flyover movie and with his beautiful music. I think I have to.
So I just want to say thank you to Gerald by combining his talents of imagery, and he basically choreographed that flight over, so it was like you were visiting Jupiter yourself. And of course, mixed with Vangelis's music, it really takes you on a journey. So these and many other videos that we've made with Vangelis are on YouTube or on our website, but you can find them on YouTube by just Googling NASA Juno. And many times you could just add Vangelis's name. In this particular one, it's part of Juno to Jupiter's album that he recently put out. And this piece is Hera, Queen of the Gods. And so if you just Google that, you'll find that exact video. The image credits, of course, go to NASA and JPL, Caltech, and Gerald himself. And the video credit is really Gerald and just Vangelis. So I just want to point out that what you heard was how Gerald processes things, and of course he has very special talents. But our website, which allows, is designed to allow interfaces at various levels. And so while you can process the images like Gerald does and actually get a lot of excitement, and you might be the first human to actually see that image, and I think he's experienced that a number of times, being the first one to see various things, certainly the cloud motion. I don't think, until he did it, nobody had seen it. But you can also go on with less technical capability and actually take one of Gerald's images or any one of images that are posted up there and change it, through simple things like changing the color or add things to it. You can try to do science, you can do things for fun. And in fact, staying with this whole art science theme, which I think mixing with the music and this, it's a little bit of art and science mixed together. There are many people, there's a fair fraction of the images that are put on our website that are actually just art. And I'll just show you a couple of those. This one was posted and made by somebody that you're able to put your name or whatever you would like to be labeled. Hubert posted this and called it Space Pomegranate. And so clearly this is a Juno image processed a little bit differently than what Gerald does, but nevertheless, it's a piece of art. And while I think the processes that Gerald do, I'm happy to have hanging on my wall, I'm also happy to have this. And here's another example by somebody that, similar to Gerald, does a lot of science with us, Kevin Gill, but then Navaneeth Krishan took it and put a different palette on it to make it much more artistic. And this is one of those vortices. And it's just a really beautiful collection. The other thing I want to point out is Steve Levin's program that he described. The Gabriel program is designed to interface with kids all the way down to middle school through high school. And they regularly interface with not only Steve, but we train the teachers. The program goes on in the schools, and then they get involved, and there are WebEx and Zoom calls to answer questions. And many of those students have gone on to be official collaborators, as he pointed out with us. And so we always are looking for new schools to join the program. And so I hope you'll reach out to us either through the EGU or directly through the Juno website. You can reach us and interface with us, and we'll get you started on making images or educating kids. And so
and I'll point out you can do both of those, Gabriel or working on the Junocam data, essentially from anywhere with an internet connection.
And so I think that concludes everything we were going to say. That was a backup slide. So thank you very much. We'll take questions.
Thank you, everyone. Yes, applause is certainly fitting. I don't know about you, but we've had a lot of space-themed press conferences by EGU and others that I've attended in the past, but this was certainly a very unique take. So thank you to all of our speakers today for that. We will now move to the last part of our press briefing, which is the question and answer round. So I open the floor to questions from journalists both present in the room and those who are joining us virtually. Just to recap, if you're in the room, you can raise your hand and I will come over with a microphone for your question. And if you are joining us virtually, then you can use the Zoom hand raising function or simply just type in your question in the chat. Thank you.
So, hi, I've got a small question, I guess, to all of you. It's more of curiosity. Are you aware if any of your images has been already used for a movie or science fiction movie or stuff like this, for instance?
I know that they've been used in various documentaries and other films, but I think that there were some like Hollywood movies that might have used some images of Jupiter, but we did not necessarily interface with them. You know, when people go onto our website to post their images, they're permitted to choose their own copyright restrictions. So Gerald always allows his to be public domain, so anybody can take it and do whatever they wish with it, commercially or anything else. Other people retain some copyright privileges, and we don't necessarily interface to protect those, but they're listed and they have a right. Since they make the image, they literally own it. We do it. That's very different than other NASA images that are typically all public domain, because people like Gerald actually make the images. They can choose that copyright, and we're different also than most missions is that we don't necessarily have a science team that's tied to that camera. So we designed it to do this right up front, and we hoped that the public would get engaged and make the images for us, and we designed the website to do that. And we were a bit shocked, pleasantly shocked and surprised when we flew by the Earth in 2013. We were flying by and we took a couple of images to test things out. We didn't have the website completely up and running, but we put together sort of a beta version of it. And then you know, the data came down in the middle of the night. We were in Denver at the time, meeting to watch over everything, where our spacecraft was built at Lockheed Martin. And so we went to sleep knowing the data was going to come down. And by the time we woke up, there were the Earth images. And we were like, wow, this is going to work. And it was actually people like Gerald, who lived in Europe and were working while we were sleeping. So, and from there, just it's been a great program to be involved with. And of course, to see art coming out of it as well, to me is very satisfying because I'm a big proponent of the combination of art and science. And so it's really pleasant. But I don't really know, maybe one of you guys know about Hollywood thing.
I was going to say, I'm not sure I've seen anything, at least that I noticed, in a motion picture, a Hollywood kind of movie. I'm quite sure I've seen some Junocam images in music videos. And I know that I've seen calendars in the store that had images that looked like they came from Junocam. I haven't checked to verify who produced what, but I think they're getting out there. I even think I've seen an advertisement or two that might have had some of our stuff in it.
Yeah, I was several times contacted by TV stations from Japan and England, and for documentary purposes. Mm-hmm. I think the Japanese production was about Juno. Mm-hmm. And I think mostly BBC productions have been documentations about our solar system, and they used it for their series. And I've also seen that in the German TV, so it's spread out in other countries too.
Yeah, and if you expand it beyond the Hollywood movies, there's quite a few music videos. And I work with a lot of musicians, not just Vangelis. I mean, he was actually a close friend, but there are many musicians and artists that I've worked with that have incorporated not only our images into their work or concerts even, but even the sounds. We convert the plasma wave data into sounds, and Vangelis has that on his last album, but so does Trent Reznor from Nine Inch Nails did some stuff with us, and country music bands have put it in. Brad Paisley, I don't know how. Little Big Town did some things where we remade Elton John's Rocket Man and incorporated that some sounds from Juno. So that's kind of spread around quite a bit.
Thank you. We have another question. I'm just going to give you the mic.
Yeah, just a quick one. I was just amazed how detailed these images are that are coming out, and I was wondering what kind of spatial resolution you achieve, what kind of structures you can still resolve.
3 kilometers, I think, and when the probe is about 3,500 kilometers above Jupiter, but for the moons we make it a lot closer, and so there we may have resolutions of a few hundred meters.
1 kilometer for Ganymede. We were 1,000 kilometers away, and we'll be closer at Europa in September, 350 kilometers or so. But one of the things about the camera I just want to point out, because it was a very different camera than anything that had ever flown on a spacecraft before. And it's not a lot different than the framing of your smartphone, which is very unique for a space camera. It's not a smartphone camera. It was actually built by Malin, who built a lot of cameras for Mars, and I asked them to design something very special for us. But the goal was that we were spinning, and we needed something that could work as a spinner. And we also didn't have a scan platform because we were an inexpensive program trying to do a flagship mission, really. And so when we went over the poles, I wanted to be able to see what those look like, right? Our whole team was curious, which is why one of the main reasons we put the camera on there. And so it was important to be able to take one picture and see mostly the whole pole, because you weren't going to be able to make a mosaic that you often get from something like Cassini or Galileo or even Voyager. And so the framing is very wide. And it turned out that'd be very valuable, because it gives you the context and the beauty that you get to see. And so I think the lesson from that is that type of camera might be something you should include in future payloads, and not just the telescopes, because it really connects to the public and gives you this incredible connection.
Thank you. Do we have any other questions? Okay, yeah, I'll just give you the mic.
Yeah, this is Glenn Orton. I'm on the team. I'll take an unabashed, unashamed plug for yet another way that you can get involved with the Juno mission, which is something currently in beta test, NASA's Zooniverse, ZOONIVERSE. 9 hours of jet lag will do this. And it's called the Jovian Vortex Hunter, in which you can sign up to measure what you think are vortices in the frame and try to decide what direction they're going in based on the morphology of the wings. And we hope that'll be online in a few weeks, and that's turning out to be very good. You can get involved with a measurement of Jupiter science based on the Junocam our product. So
yeah, that's just in beta testing at the moment, but we
Yes.
do have it started, and so that's another program that we'll be doing.
yeah.
And I'll point out that citizen scientists can get involved in the Gabbard work as well, also through Zooniverse or directly contacting Gabbard. We're expanding from just students to adults and anybody who wants to get involved.
So the real message, as you're hearing from our team, is if you're interested in space exploration, you can join our team no matter what you do,
Yeah,
or
completely.
no matter how old you are, or what your expertise is, or what your interests are. And we have a multitude of ways to do that, including, Glenn hasn't mentioned it, but he's actually, I asked him to run the amateur astronomy connection. And we've had previous press conferences where we showed a discovery by an astronomer named Clyde in South Africa that was called Clyde Spot. So you got a telescope in your backyard, you can join our team. You want to get on the website, join our team. You want to go to school and learn about space, you can join our team. So we welcome you, and hope that
Even if you're a professional astronomer, you can join our team.
they're already on it. So it's-
They are sort of, so we involve all of that together.
Thank you. So if we have no other questions, then I think we'll wrap up our press briefing. We've kind of overspilled, but sometimes that's a good sign. Thank you, everyone. Thank you to all of you who've joined in today, and thank you to our speakers. I just want to say that if you are struggling at any point to get an interview or a comment from our speakers today, feel free to drop me an email at media@egu.eu. And this was the last of our press conferences for EGU22. Thank you for your attention and for joining us. And once again, thank you to all of you.
Thank you.
Thank you.